ways, it's the same thing as a type 1. Understand? All right, and then in here is the f of xy. Now, there's something in this problem that kind of gives it away that this is going to be a type 2. What kind of gives it away?
Y squared.
That y squared. You see it in there? You see this right here? Y squared is equal to 2x plus 6. If you try and turn, well, let me go back. This right here, you could say is a function of x, right? Y equals some function of x. Y is x minus 1. This one, though, to turn it into a function of x, you'd have to solve for y, which means you'd need a plus or minus, right, when you take square root. And so you're actually going to have two functions there, and that's the problem. It would be easier to solve this for x, wouldn't it? And then this one would also be easy to solve for x. Okay. Let's see if we can draw this, though. Y equals x minus 1. That should be easy for all of us to draw, right? Y-intercept of -1 has a slope of 1. Looks like this. But how about this one? How are you going to draw this? It's a parabola, right? Sideways. So let's see how we could do that. Let's go ahead and try and solve this. Let's solve that for x. We get y squared minus 6 equals 2x, right? If we divide both sides by 2, we get 1/2 y squared minus 3 equals x, not 0. And just rewriting it in a different order. Now, in the back of your mind, you could do this. Just think about, what if it were switched? What if this were y and that were x? Then would you be comfortable graphing this? What is that? X squared parabola. Half parabola makes it wider, right? And then moving it, what? Down 3? So this is the same idea except sideways. And so it's a parabola that opens up sideways, right? But it's wider, and it's, what's down 3 mean for us sideways? It means to left 3, right? So remember, positive is that direction, so negative is this direction. Just like here, positive was up and negative was down. So it's the same idea, just this way. And then we draw it. -3 is over here. And I don't know. They're going to hit, right, somewhere. Y'all good? Type 1? Type 1? Type 2. So let's look. If I try type 1, if I draw a double arrow right here, right, the blue function is on top of the red function, and that works. But as I move that over to the left, what happens eventually? How about when I get over here? Blue on top, blue on bottom. Same function. That's a problem. And that's why you can't do it as a type 1. Because this curve is the same as this curve, right? So technically, when I try and do the top curve minus the bottom curve, over here, I'm going to get 0. Something's going to go wrong there because it's the same function, same curve. So type 1 is no go. But if we do type 2, we draw these little arrows sideways, horizontally, then move that up and down through here, no matter how you do it, the blue one will always be the left bound. The right one will always be, the red one will always be the right bound, won't it? No matter what. So better suited for type 2. For sure. And because it's type 2, what I need to do is rewrite these curves as functions of y instead of x. So can you tell me what this blue curve is as a function of y? We got it and solved it for x, didn't we? That creates the function of y right there. This left side gets replaced with, what letter are we using? H. H sub what? 1 or 2? 2, 1. The one on the left is 1, right? Okay. So h sub 1 of y is what? 1/2 y squared minus 3. Yeah? Then this red one, which is our right bound, is our h sub 2 of y. And that is the line solved for x, which we hadn't done, had we? We hadn't solved this for x, but we could. Y plus 1. Y plus 1. Right? So take this. That's x equals y plus 1. That's how I got to this. That's an arrow. No questions? What else is still out here for me to resolve? Bounds on y. So we want to know where these hit each other still, right? But we want to know that point and that point, because this is going to be our D, and this point down here is going to be our C. So you see, it's everything just sideways. Same picture, just turned, rotated, basically. So how do we figure out where these two hit each other? Set them equal to each other, right? Set the functions equal to each other. In other words, set this equal to this, right? That will give us our intersection. So I'm going to set 1/2 y squared minus 3 equal to y plus 1. Notice that the equation that I'm using here has y's in it, so my answers are going to be y values, which is what I want because my type 2 region should have constants for y's. This is a quadratic equation, so if I were going to solve that, I would just clear out the fractions first, multiply everything by 2. And then I get everything to one side. What, minus 8? And then I'd hope it factors. And if it didn't, I'd use a quadratic formula. But it should factor. Minus 4 plus 2 are the factors. Y minus 4, y plus 2. Two solutions, 4 and negative 2. That's reassuring because I should have two y values where they hit each other over there. So, feeling good. C is going to be the one below, so negative 2, and D is going to be 4. Now it's just write the integral. That's all it is now. All right, here we go. Double integral. What are the limits on the first integral? Negative 2 to 4. And then second integral, what's the limits? 1/2 y squared minus 3 up to y plus 1. The integrand, xy d x dy. There we go. Would you like me to work this one, or do you want me to just say dot, dot, dot? Dot, dot, dot? Okay. On the homework videos that I did for this section, I worked through the first couple so you can see all the little details of plugging in and. Okay. What do you all think? I'm not quite sure how to gauge what I'm getting from you all right now. Are y'all tired? Y'all ready for summer or what? Remember, we're like halfway through the semester. It's not like Christmas break, or it's not like Thanksgiving where you come back from Thanksgiving, there's like a week or two of school and then it's all over. No, we still got a long way to go. So deep breaths. There was the region. I'll do this one quickly. It's kind of an interesting solid. There it is. Find the volume of the tetrahedron bounded by this, 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 and this. And so what's a tetrahedron? What's tetra? Four? A pyramid is an example of a tetrahedron, kind of. I did give you a tetrahedron on the first exam. Exactly. Yeah, so look, the reason I didn't say pyramid was because I think the standard pyramid that we think of has like, one top and then four corners on the base. Tetrahedron, we're going to have four-sided. It's going to be four surfaces, four faces. This would have five, wouldn't it? Okay. So I have a tetrahedron that is formed or bounded by this, which if we graph this is a what? A plane in three-dimensional space. What is this? A line in two-dimensional space, but in three-dimensional space, it's a what? It's a plane. X equals 0, what's that geometrically? A line in two-dimensional space and the YZ plane in three-dimensional space. Remember one of our first conversations we had, like, what does X equals 0 look like in R1? What does it look like in R2? What does it look like in R3? Okay, so understand what the question is asking here is, you have one plane, two planes, three planes, four planes in three-dimensional space. They enclose some solid. What's its volume? Now, if we want to say we're only looking in two-dimensional space, I agree, that is a line, and, well, Z, hold on, we're in 2D, so Z wouldn't count, would it? So how in the hell are we going to draw this? So let's agree with something here. Let's try and draw this. I don't think we've ever tried to draw a plane the way I'm about to do it. Let me just try and draw. There's my X, my Y, my Z. All right, let me try and find if this plane hits the x-axis. Does this plane hit the x-axis? If so, where? So if you're on the x-axis, what's your y-coordinate? What's your z-coordinate? So if y and z are both 0, what's x? 2. So do you agree I would be out here too? That point lives on the plane? Agreed? What about the y-axis? Does it hit the y-axis? At y is 1. So this time, if you're on the y-axis, x is 0 and z is 0. So you would get just 2y equals 2, so y would be 1. That point lives on the plane. And what about the z-axis? Where does it hit the z-axis? Up at 2? So what I can tell you right now is that this plane passes through all three of those points. So if I connect them with lines, that triangle lives on that plane, doesn't it? But it still extends in every direction forever. All right. What does x equals 0 look like? If I graphed it? That's the YZ plane. Isn't that this wall right here? So it's the entire wall, isn't it? Doesn't that kind of like close off the back section of this tetrahedron we're creating? Y'all see that? That's like a back wall of that tetrahedron. What does z equals 0 create? XY plane, which is the floor, isn't it? So everything down here. And then, one more thing. There's one more plane that we need to look at. X equals 2y. So what, that looks like a plane, right? Could I draw it on here? Can you draw me the plane x equals 2y? Can you tell me one point for sure that it goes through? The origin, right? 0, 0, 0, 0, 0 lives on that plane, doesn't it? If x and y are both 0. So let's see what color I've got left here. I know this point lives on the plane. What other point lives on this plane? Give me something, again, let's draw something that's on the xy plane. So let's let z be 0. Give me another solution to that. X is 2, and y is 1, right? X is 2, 1, 2. Y is 1, I think somewhere around here, right? Do y'all agree? Do y'all see that? 1/2 and 1 would have worked. I'm sorry. No. 1 and 1/2 would have worked. Right? 1 and 1/2? That would have been 1 and 1/2. What I'm trying to get at is that this plane, because z is not in here, goes straight up and straight down. So it looks like, it looks like this. It's got a certain tilt to it because of this equation. In fact, if we draw this and connect these on the ground, right? That's the line that it hits the xy plane in. So I don't want to draw this plane coming out, okay? Because I think that's going to cause a problem if I try and draw it out. Imagine that this comes up through our tetrahedron. Do you see the double integral? Do y'all see it? Remember, the double integral gives us the volume underneath a surface above some region. Do you see the region in which we would want to integrate over? Do you see it in there? Okay, let me ask you something. Do you see the surface on top? I need to go get the, what do you call it? How do you say that? Defibrillator. Y'all okay? I'm asking a yes or no question. Do you see the surface? If you don't, then you need to just tell me and I'll try and show you where the surface is. Look, we have a surface on top, and on the bottom we have some domain that we're trying to go straight down in there and get that volume underneath, right? That's what we're trying to do. Okay, do you have a top surface? Okay, where? What is it?
The red triangle.
The red triangle. The plane, right? This right here. That right there creates a top surface, doesn't it? Doesn't it? And if I can just find the volume below it, then I can answer this question, but it's the thing on the bottom is what we have to look at a little more closely. So can you write this as a function of x and y? Yes. As a function of x and y, this is
2 minus x
2 minus x minus 2y, right? If I solve that for z. So that, to me, is going to be the upper surface. I'm going to be trying to find the volume underneath it. When I look down to the ground, though, go straight down from here, do you see the domain that I need to work with? Do y'all see it? Yes? Okay, thank you. Where is it?
The black triangle
The black triangle?
between the blue line and
Right in here. Just this in here. Okay? Just that. It's difficult to see this because I'm trying to draw 3 dimensions on 2-dimensional sheet. Look, if this blue wasn't here, we would have a tetrahedron that would have this plane, the XZ plane as a wall, the back would be a wall, and the floor would be a wall, and that would be a tetrahedron, right? But there's one additional thing. We're coming through and we're taking that and we're saying we're slicing it right through, and we're cutting through. See, it's impossible for me to really be able to show you where it cuts through, but it does cut through, and it creates that tetrahedron. I don't know if that helped. Okay? Now, it all makes sense now. That helped a lot? See, that's why I have this. This, whoa, shit. Figure out where I am here. Okay, there's the plane, right? We all agree this is the plane? Well, I didn't show much here, sorry. I thought I was going to show more detail. There you go. All right, so that's it right there. Do you see where that plane came through and sliced that thing right there? That's what I was trying to show in here, is that slice through there. All right, back to business. That's why I'm asking y'all questions. That's why I appreciate answers, because I probably wouldn't have drawn that slice unless y'all showed some resistance. But when I ask and no one says anything, I'm just assuming you're getting it, I guess. I don't know. Or you don't care enough to tell me you're not. All right. Let's draw the domain on the ground, now that I've erased that beautiful picture. X and Y. I already know my surface, right? I already know f of xy was 2 minus x minus 2y. What does it look like on the ground, though? Maybe I shouldn't have erased it, huh? We had this point, it came over, but then I came through and I cut through that way, didn't I? And the region I was talking about was this one in here. Remember, this is the y-axis, this is the x-axis. So can you label at least one point that you know for sure? 0, 0 is here. And 0, 1. We all agree with that? That corresponds to this one and this one. The other point is where these two intersect each other, right? Which is where what intersect each other? This plane, where that plane hit this plane, right? That's what you need to know. Where do those hit each other? So how can you determine where those hit each other? Well, where they hit each other, they're both on the ground, right? XY plane. So when they hit each other, z is 0. So I'm first going to let z be 0. That way I'm on the ground. And I'm going to rewrite, let's see, the first equation is this. The second equation is this one with z being 0, is x plus 2y equals 2, right? If z is 0, that's what the plane is, and that's what that plane is. 2 equations, 2 unknowns. I see a simple way of doing this, right? If this is 2y, plug it in there. Or if this is x, plug that 2y. Either way. I'll just take this one, I'll replace x with 2y. So 2y plus 2y equals 2, 4y equals 2, y equals 1/2. If y is a half, what's x? Which implies x is 1. So that's where they hit each other, at the point 1, 1/2. So that corresponds to this point right here. 1, 1/2. And we all agree that that's my D? Yeah? Questions? What am I going to ask myself next? What kind of region is that, right? Do I want to treat that as a type 1 or a type 2? You could do either, but one of them's easier. Look, let's look at type 1. If I do type 1, then if I move from left to right, does the top and bottom curves always stay the same? Yes. If I do type 2, do they always stay the same? Here, this one is the one on the right. The one on the left will always be this line, right? But see, once I get up to here, it switches to a different curve, doesn't it? So I could do type 2, but I'd have to split it into 2 integrals, and I don't want to do that, so I'm going to keep it as a type 1. Yeah? So I'm going to go with type 1 on this. Type 1. I didn't do this before, but I'm going to go ahead and put my restrictions that I know. I know x is restricted between 0 and 1. Now, I didn't do this before. I'm just showing you a different sort of approach, different notation. All right? Now, what's your restriction on y? It has to be a function. This is a type 1 region. So you cannot just say between 0 and 1, because as you move this left and right, your y value is not free to go as high as you want. Well, you can't go all the way up to 1 here, can it? It's got to stay underneath that one. So we actually need to come up with those two curves. What are those two curves? So do you know what this curve is right here? And do you know what this one is? The bottom one came from this, didn't it? And you could check it, 0, 0 lives there, right? And then if I plug in 1 for x, well, hold on. Wait a minute.
Yeah, that's right. Oh, yeah.
Yeah, x is 1. Sorry, yeah, you get... All right, I had a little panic attack there. So the bottom one comes from this equation, x equals 2y. We agree? The top one comes from what? I mean, isn't that where that plane comes in and hits the ground? Let me see if I can rotate this around. Okay. There's that picture, right? Where that plane came in and hit the ground right here. Isn't that what we're talking about? And that means it comes from the equation of the plane when z was 0. So what's the equation of the plane when z is 0? It's x plus 2y equals 2. Now this is a type 1 region. So I want to solve both of those equations for y. So this should be y is equal to negative 1/2 x plus 1. Solve that for y. Solve this for y. Y is equal to 1/2 x. And in terms of matching up with what the formulas we're using, this one would be g sub 2 of x. This one would be g sub 1 of x, wouldn't it? Okay, so now writing it this way, what's the lower limit of g, or of y, sorry? 1/2 x, and the upper would be negative 1/2 x plus 1. There you go. That should be everything we need to set up the double integral. See, you can tell these kind of get a little messy with the, just the visualization of things. So double integral, 0 to 1, 1/2 x to negative 1/2 x plus 1. What are we integrating? Z equals 2, so 2 minus x minus 2y. That was that surface right there. And then d y dx. There we go. Dot, dot, dot. So when the final comes around and I ask you a problem like this, it will be set up the double integral. Do not evaluate. Okay, so you'll just set it up. I mean, there will be a problem. There will be at least one problem on the final where you have to evaluate the whole thing. But setting up, getting to this point is where I want you to get, so we can, not waste time doing integration. All right, that was interesting. Example 5. Order might matter. This looks harmless enough. I love this problem. This is outstanding. So you look at that and you're like, all right, sure. Trying to find the volume below this surface over some region, and I just have to be able to compute that, right? And then you go, wait a minute, what's the antiderivative of sine y squared? So you go to Wolfram alpha, and you type in integrate sine y squared. And it returns to you the square root of pi